video, we're going to look at turning standard form of a polynomial into factored form by using box division. So you see in this first example, we are given a standard form polynomial and asked to rewrite it in factored form. Now it also says here as a product of linear factors. Rewriting it in standard form or rewriting it as a product of linear factors, both of those two things are asking us to do basically the same thing. It's just two different ways of saying make it into factored form. So if you see it in the instructions to write it in factored form, or if you see it in the instructions to write it as a product of linear factors, both of those two things mean to do the same thing. Now, in order to do that, we often need to have at least one factor that we know to start with. In this first problem, they don't give us the factor, but they do tell us a 0, which gives us enough information to be able to figure out one of the factors. If there's a 0 at x equals 6, then we know that that means that there is a factor at x minus 6. Because if I put x minus 6 as one of the factors, and I put 6 into that problem, it would create a 0 there. So first thing I'm going to do is divide by x minus 6. Since that's the factor I know, that goes along the side. X minus 6. And then I'm going to fill in the boxes with these terms here to figure out what the other factors are. So I put x cubed in the first box, and then above it I write what I multiply with this x over here to get x cubed. So if I already have one x here, I would need x squared on top, because x squared times another x makes x to the third. Then down here I need negative 6 times that x squared from the top. The top times the side fills in that box. So we did above, below, now we're going to the diagonal. And remember, the diagonal says add these two boxes, negative 6x plus whatever we write here should add to be a positive 2x squared. So I know I need to go up from negative 6 to get to positive 2, and I'd have to go up by 8x squared. Negative 6 plus 8 is positive 2, and they both need to have x squared so that they can create 2x squared when we're done. Now we go above, below, diagonal again. So up here we're going to have plus 8x, because 8x times x makes that 8x squared. And then 8x times negative 6 makes negative 48x. And then another diagonal. This time the diagonal should add to negative 33x. So if I'm already at negative 48, I know I need to go up, because I'm getting closer to 0. And negative 48 plus 15, and we'll need the x with it, will add together to make negative 33. Negative 48 plus 15 is negative 33. So then I put plus 15 up here, and 15 times negative 6 makes negative 90. Now if the instructions were just to divide, we would be done at this point. We'd have x squared plus 8x plus 15. But we want to make it into factored form. So right now we could say partially factored. This came out to x minus 6, the one we knew up here, and that multiplies by x squared plus 8x plus 15. But this part factors more. This is where we need to break out that little 2 by 2 quadratic factoring that we learned. So I make a 2 by 2 box, and I fill in this x squared in the front corner, and I know that's got to be x times x to make that. 15 goes in the opposite corner, and I list out all the ways that I can multiply to 15 because I know that this number up here and this number over here multiply to be 15. So I come over here, list out the factors of 15. Could be 1 times 15. Could also be double negatives, so I include that on my list. So negative 1 times negative 15 also would come out to positive 15. Or could do 3 and 5, or negative 3, negative 5. Then to pick out which one is correct off that list, we're looking for the ones that add to be the right middle term. Because I know that these two boxes add together to make 8. So if I look through this list, here's the pair right here that add together to be 8. So we put plus 3 on one side, and we put plus 5 on the other side. That gives me 3x and 5x. And if I check that out, we've got x squared. These two make 8x, and 15 at the end. That is the right factorization for that. So our final answer for this, we'd say f of x equals, and then our three factors, we started with x minus 6, and then the other two are the ones we got from the sides of this box, x plus 3 and x plus 5. And there's our factored form for that first problem. Let's go on to try the second one. This one's a little bit more difficult. Now, the first thing that makes this one a little bit more difficult is the fact that it's higher degree. This one's 4th degree, which means that we're going to need more factors known. In this case, they gave us 2 different factors that we know. We know 2 of its factors are x plus 2 and x plus 3. So what we're going to have to do is divide by each one of those in its own box. But before we get to that point, there's something else that we can do to make our lives a little easier here. We can look for a GCF, a greatest common factor. That's a number that I can divide each one of these parts by and get whole numbers for every single one of them. So in this problem, I notice they all end in a 0. And I remember that numbers that end in 0 can be divided by 10 pretty easily. So I'm going to divide every one of these by 10. Now sometimes you might see ones where you can divide by 2 because they're all even. Or sometimes you might see one where you can divide by 3. As long as you can divide every number by the same amount and get no decimals, then we know we've got a GCF that we can take out. So in this first problem, we didn't have a GCF because there wasn't anything that I could take out of 1x cubed, 2x squared, negative 33x, and negative 90. Because this was only 1x squared, the only thing that goes into it is a 1 or an x. If I divide by 1, it doesn't do anything. And if I divide it by x, well, I couldn't take x out of this 90, so there was no GCF to pull out of that one. But in this one, every one of these can be divided by 10. So I'm going to do that. 10x to the 4th divided by 10 is just x to the 4th. 30x to the 3rd, divide that by 10, is 3x to the 3rd. Negative 120x squared, divide that by 10, is negative 12x squared. Negative 520x divided by 10 is negative 52x. And negative 480 divided by 10 is negative 48. Now the thing is that 10 doesn't just disappear. It's one of the factors, so it needs to get listed next to the other factors. So that 10 is going to stay in front of the problem, so that if I distribute it back into the problem, 10 times each one of these would get me right back to where I started. So that 10 has to be there if I want it to be equivalent to this one. But now that I've taken the 10 out, these numbers are smaller and easier to work with. So now I can take that x plus 2, the factor that I know, and put that down the side of the box, and fill in the box based on these smaller numbers. So we put x to the 4th here, which means I'm going to have x cubed up top, because x cubed times the x on the side makes x to the 4th. And then down here it's going to be 2x cubed. Then I do a diagonal. These two have to add to make 3x cubed. So if I'm already at positive 2, I just need to go up one more x cubed. 2x cubed plus 1x cubed makes 3x cubed. That means up here I need 1x squared. And then I can multiply the top times the side to fill in this bottom box. 1x squared times 2 is 2x squared. Then another diagonal. This time we need negative 12x squared. So if I'm at positive 2, I need to go down to get into the negatives, down by 14x squared. 2 minus 14 is negative 12. So that means up here I'm going to put negative 14x. And then negative 14x times the 2 on the side makes negative 28x. And then I need another diagonal. So I'm going to need to extend this box out a little further here. Negative 28x plus this box needs to make negative 52x. So if I start at negative 28, I have to go down some more to get to negative 52. And it would actually be down 24x. So I put negative 24 up top. And negative 24 times 2 makes negative 48. And that is correct because the bottom corner ended up matching with that negative 48. Since we were told it was a factor, we knew that that should come out right in that bottom corner. So what I know right now is there was a factor of 10 that we took out first. Then we took out this x plus 2 factor. And now we're left with x cubed plus 1x squared minus 14x minus 24. That's just these numbers across the top. But we need to keep factoring because we want to make it broken down into as small of factors as we can. So what we're going to do now is we're going to take this part here and we're going to make another box using that and dividing it by the x plus 3 factor, this factor here. So I'm going to put x plus 3 down the side. And now I want to fill in based on this part. So x cubed goes in the first corner, which means I have x squared on top. x squared times 3 fills in the bottom box. We did above, below, and now the diagonal. So these two have to go together to make positive 1x squared. So if I've already got positive 3 and I only want 1, that means I need to go down 2x squared. Those two, positive 3 minus 2 makes 1, and they have to both be x squared so that this exponents will match. Then I go up top and I just put the negative 2x. Negative 2x times the x from the side gets me to that negative 2x squared. And then I go down here. Negative 2x times 3 is negative 6x. And then another diagonal. Negative 6x needs to add with this box to make negative 14. So if I've got negative 6, I need to go down by 8. It needs to have the x so that they match. Negative 6 minus 8 makes negative 14. Means up here I put the negative 8. Negative 8 times x makes negative 8x. And negative 8 times 3 makes negative 24. Again, that bottom corner matches what I wanted it to because I knew it was a factor. They told us we know these are factors, so we know that we should not get a remainder when we divide by them. So at this point, it's broken down into 10, and then x plus 2 from the first box, and then x plus 3 that I took out in this green box, and x squared minus 2x minus 8. Now if they told me a third factor, then I would just do another box and divide by that third factor. And I'd keep going until I get it down to a quadratic, which this is now down to a quadratic. If I look at this part right here, that's a quadratic. It's got x squared, so I can break that part down using just a little 2 by 2 box. So I put x squared in this corner, which is x times x. I put negative 8 down here. Then I think of all the different ways to get to negative 8. So the factors of negative 8 could be negative 1 and 8, or positive 1, negative 8. Could be negative 2 times 4, or 2 times negative 4. I know I always have to have one positive, one negative if I want to make a negative 8. And that's the whole list of ways to get to negative 8. So then I look for the ones that add to be this middle number, negative 2. And that would be this last pair. 2 plus negative 4 add together to equal negative 2. So I put x plus 2 on one side and x minus 4 on the other side. And if I fill those boxes in there, I can see I've got x squared. These two together make negative 2x and negative 8. So final answer for this whole problem, we would have g of x, so that was the name of the original function. The 10 we took out the very first thing. The x plus 2 and the x plus 3 that we took out, that one was from the blue box. The x plus 3 was from the green box. And then in this last box, we've got an x plus 2 and an x minus 4. And that's the fully factored form. So you could write it like that, or a lot of people would take that x plus 2, and seeing that there's 2 of them here, you could write it with a multiplicity instead. So the other possible answer you could give here would be 10. And there were 2 of those x plus 2's, so we just put x plus 2 squared, because there were 2 of them, and an x plus 3. There's only one of those, and only one of the x minus 4's. So either one of these two would be an okay factored form answer there. Hope that helped.